Refraction is the change in direction of propagation of a wave when the wave passes from one medium into another and changes its speed. The velocity of light is different from different transparent media. When light passes from one medium to another, it changes direction and speed. Reflection is a abrupt change in the direction of propagation of a wave that strikes the boundary between two different media. When light hits an object, part of it is absorbed and part reflected. The reflected light enables us to see things. As we can see in the simulator, when the medium changes, the angle of refraction changes and the velocity decreases. The angle of reflection only changes when the initial angle changes.
Snell's law talks about the relationship between the angle of incidence, that is the one formed when the ray reaches the barrier, and the refraction angle, the one from the refracted ray. Now they may be different, but they still have a relationship and is given by this equation. This states that the refraction index of the first medium times the sine of the angle of incidence is equal to the index of refraction to the second medium times the sine of refraction angle. This is often used to predict unknown angle values. But there are also times when light reaches a barrier to a different medium, but this time it does not refract. It only reflects back inside. Two conditions must be met for this to happen. The first one, light must be going from a more dense medium, like in this case water, to a less dense medium, like in this case air. And second, critical angle must be met. Now critical angle is just a value for the incidence angle, so that the refraction angle reaches 90 degrees. In this case, light cannot pass through the surface and must all reflect back inside.
Diffraction is the spreading of a wave as it goes past an obstacle or through an aperture. Diffraction takes place when a wave with wavelength comparable to or larger than the size of an aperture or an obstacle moves through or past the aperture or obstacle. In general, the larger the wavelength, the greater the effect. Interference, it is the resulting pattern when two or more waves meet at the same point in space. The resulting wave has a displacement that is the sum of two individual displacements. The path difference is the difference in distance of the point from the two sources. When the two waves are added, the resulting wave has an amplitude of 0. The waves cancel each other and vanish. This is called constructive and destructive interference. Constructive interference occurs when the waves are in phase, meet crest to crest and through to through, and the path difference is the following. Destructive interference occurs when the waves are exactly out of phase, meet crest to through, and the path difference is the following. Curves in red points are constructive interference, and the ones in black are destructive interference.
The similarity between the double-slit diffraction and the single-slit diffraction is that if we only look at the diffraction, there is none, but the difference between both is in the interference, as the diffraction also passes through the slit, but with an interference pattern. This produces regions of constructive bright fringes and destructive dark fringes, interference and a very bright spot at the center of the screen, called the central maxima.